Hello everyone. In this lecture we will talk about low impact design. So how to exert actually low environmental impact on the environment is I think a matter of concern for each one of us, like how we can go about it. So we will take actually some examples from like a different domains of like design, and we will discuss one by one. So if you see from a sustainability perspective, it is very important to pick materials and products with the lowest environmental impact. Organic materials such as like wood, wool, natural stone seem like an obvious choice for our like selection. But we must not forget that natural resources need to be treated actually responsibly. Choose materials that are quickly renewable, such as like fast growing bamboo. That material can be regrown very at a very faster pace, and the extracted and these are the materials which are extracted in the environmentally responsible way. There are like a labels, standards and certifications that give actually credible information about the product's origin and help you identify eco-friendly products. For example, you may have seen these FSC labels on the wood related products, which ensure that the wood used in the product was harvested actually sustainably from like managed forests. The environmental impact of materials and products must be evaluated throughout the entire life cycle, from extraction, production, transportation, and processing, all the way like how they are discarded after their use. There are standard actually tools and labels that help designers understand and compare and evaluate a product's environmental impact in distinct phases of their life cycle, such as the LCA. So LCA is one of the tools where we can analyze a particular product or a particular material, like how it was used in this particular product. So if you see for example, I have taken this example of a commercial yarn actually, which is known as like a EcoNil. So how it is improved actually for like a suitability to reduce actually the carbon emissions through its like an entire like life cycle. So you can see from the beginning. So it actually extracts the raw material, okay, and then it goes for like a processing. Then the actually is go for the like a fabrication. Okay, then it goes for like a further processing. There are like some chemical process, and the product is actually made out of this process. Okay, and then it gets supplied to the market. So this is actually a normal actually a cycle of like any product. Okay, and how about this econil? So how they have actually differentiated themselves from like any generic process in the beginning scale only. So in the first phases of the like a cycle life cycle of their material, their like a yarn. So there only they actually adopted some strategies resulting into like a 58% saving of like a carbon dioxide emissions through this sourcing of this polymer compared to like any other like a virgin polymer. Okay, so this uses actually this regeneration actually system in the coproclactum actually production actually process. So from there actually they take this material for like a further like a processing, and in overall actually sense they have actually tried to reduce the actually CO2 emissions. So similarly, in the similar fashion, there are several companies and corporate sectors who are actually who are actually exploring several actually ways for like a reducing like a carbon emission actually footprint. Like for example, if you see this carpet tiles over here in this picture. Okay, so this is a tweet from that company which talks about like a Deso Air Master has been specially developed to capture and retain harmful fine dust from the indoor air carpet. So we were talking about like improving indoor air quality. So there are like IAQ indexing also. So how much of like IAQ can be like tolerated, and how much it reaches once we have to intervene to improve it. So this actually carpet retains the fine dust which gets accumulated in the atmosphere over here, and further which can be actually cleaned from the vacuum and all. So this talks about like a Deso Air Master carpet tiles made from like 100% regenerated econil yarn are specifically designed to capture and retain fine dust. As a result, they contribute to lower air pollution in the environment and reduce the risk of health problems. This is actually concept for actually at least solving like a one aspect of the overall like a sustainability issues which are happening in and around us. And this is how actually corporate, this is how the actually manufacturing sector, this is how actually like a different companies are actually contributing to the overall cost. Another example from the same company, uh, this actually piece of like a carbon over here, carpet over here is named as a ECONYL, like a stay clean nylon yarn, is a strain resistant actually sustainable yarn for carpets that can be easily cleaned with the water only treatment. Because the stain protection is permanently built into the fibers, the carpet can be stained and washed several times without losing this anti-stain characteristics. So it reduces actually the need of the detergent. It reduces the actually several other like processes. Okay, so it reduces actually the harmful uses of the cleaning agents, the detergents, and several other types of like a cleaning materials used for like a carpets. So that kind of actually this compound is coated on the fiber of this carpet itself, the yarns of this carpet itself, so that it can gets easily cleaned by using simple water. So we saw like a several like these type of like efforts. So how to go for like a waste reduction? So interior designers have actually a lot of power in their hands. This the architects and the designers and engineers have a lot of like this opportunity in their hand when it comes to like a waste reduction, and at the same time a big responsibility to act sustainably. The planet's precious resources are limited. So the mentality of discarding products as soon as they go out of style and replacing them with those that are currently trendy is no longer justifiable. So we must actually keep on using as long as the material is going to be like a last. Fortunately, the world of design is becoming increasingly aware of the need of sustainable thinking and is experiencing a growing interest in sustainable trends such as recycling, upcycling, and repurposing. Instead of discarding old-fashioned objects while they are still functional, designers can and should come up with creative ways to give them a new life. So these are actually strategies which you can apply in your like design processes. The next one, another way in which interior designers can help reduce the completion of natural resources and divert waste from like landfills is by opting for synthetic materials that were made from recyclable waste or can be renewed recycled at the end of their life cycle when they are spent or people grow tired of them. The last one, with this cradle to cradle approach, waste becomes a raw material for the new products and a circular loop of manufacturing is formed, effectively minimizing or even eliminating waste altogether. So this is what we actually learned from here, like from the like a strategy perspective. Like one should not actually discard material just for the sake of it. One should keep on using it for the like a longer period of time, for the complete longevity of that product which was like envisioned with this actually product. Or even if it is like once discarded, one should learn like how to reuse them or repurpose them into different other applications. So further going back to that company, so here if you in this image if you see ECONYL nylon yarn is not only like 100% regenerated, it is also regenerable. These discarded actually fishing nets you can see in this picture. Okay, fluff and upper part of the carpet like a fluffy those bubbly those kind of a woolly that the portion of the carpets and the plastic components will be transformed into nylon for carpets, having the same quality as the virgin nylon. When the carpets reach the end of their life cycle, the fluff can be regenerated back into new fiber without any loss of quality. So how like beautiful is this? Because most of these materials what we are seeing in this picture, they end up in the landfills, they end up in the like water bodies, and we have seen in the previous like a lecture like how several like aquatic animals are falling prey to like such pieces of like polymers and plastics. So design for longevity and design for flexibility becomes like one of the very important actually strategies to actually adopt for like our design exercises to prevent actually materials and products getting discarded like too often. Interior designers or designers should consider the lifespan of any material they plan to use, specifically for those elements that experience a lot of wear and tear, such as like a flooring materials. The goal of designing for longevity is to design durable and timeless spaces and suppress the urge to change the whole design every couple of years. The best way to achieve timelessness is to choose quality over quantity, classics over trendy, and simplicity functionality over embellishments. Okay, just see this picture. What comes to your mind? What is it? Well, it looks like a staircase, and it is a staircase. Let's see this picture. It is actually conscious effort to allow actually the vegetation to grow right beneath this staircase, and that is why this has actually taken this shape and this actually form. So you can see in this picture right over here, this is how they have actually spread this material, allowing the actually vegetation to grow comfortably right beneath it. It allows actually water, it allows actually air, it allows actually, it gives the space particularly to actually grow that grass which is right now growing beneath actually this material. So it's actually conscious effort by the designer. You know, you can see the detail over here, like a SPBR, like architects. So this is the actually firm from like a Brazil. They have used actually this idea in one of their projects, where they have actually integrated with the landscape design to have like a low impact and to actually allow the plants to grow right below them. So with the aim of having as little impact on the environment and the ecosystem of the area as possible. So this was actually approach they have adopted actually in this particular approach, which is really worth actually praising. Okay, so how to like if we see the, if you analyze the actually scenario of reducing environmental impacts of like a transport, so let's see like how much of in the number, in the terms of the number, it's causing this. So this actually data is sourced from like a European Environmental Agency. The several EU targets have been actually set to reduce the environmental impacts of transport in Europe, including its greenhouse gas emissions. The transport sector's target are part of the EU's overall goal to reduce greenhouse gas emissions by 80 to 95% by year 2050. So key targets to be reached by 2050: reduce transport exclusive international maritime greenhouse gases emission by 60% compared to 1990 level, and reduce international maritime transport emission by 40% compared to 2005. So on the share part, if you see the transport total share of EU's GHG emission in 2012 was 24.3%, almost one quarter of the total. So that's like a too big if we see for like a just one actually continent. On the on this actually table, if you see like how it has evolved, how it has grown in the like recent times. So in the year 1990, from the like in the year 2012, and how they are actually targeting the same level to maintain by year 2030 and 2050. So you can see over here like how the transport has actually grown significantly in this actually this blue line over here, but they have this target to bring it back, and that is how actually they have taken several steps to bring it back to this is the stage which was there in the initial like years. So if you see like by reducing actually international bunker greenhouse gas emissions by 40% by 2050 compared to 2050 level, so the reduction of like a minus 40%. Okay, reducing like a transport oil consumption by 70% by 2050 compared to year 2008, reduction of like a almost like 70%, and so reduce average CO2 emission of new cars to like 95 grams actually per like a square kilometer by 2020. So this is a 95 grams of CO2 per like a square kilometer per kilometer. And in this one, reduce average CO2 emission of new vans to like a 147 grams per like a kilometer by year 2020. So here if you see like this is like a reduction, what they have target they have set is like 147 grams CO2 emission per kilometer. So in overall, if you see like for each EU member state, the share of renewable energy consumed in transport must be at least 10% by 2020. So this is the target what they have set up for the EU countries. And these are the, of course, in the transportation sector, when we are talking about, these are the actually major contributors for the like air pollution. So from like smog to soot to health and so smog and soot has like a health and welfare impacts. CO2 and other greenhouse gases have like a climate change impacts on the overall sense. So these are the actually ones which we see generally on everyday life. We are also part of it on the regular basis, from like on the road, light duty vehicles, heavy duty vehicles, motorbikes, etc. And then we have like a non-road other modes of like transportation forms like aircrafts and other like off-road like heavy equipment, you know, marine vessels, locomotives, you know, trains, you know, lawn and garden like equipments also contribute to this, other recreational vehicles, etc. So if you see like what are the solutions possible for like a transportation sector to prevent like a air pollution. So from like a emission reduction, they can go for like actually cleaner air and better actually a healthy atmosphere. So what are those actually possible areas, possibilities where strategic interventions can be made? is by using actually catalytic converters. Well, they have been like forced in our like Indian scenario also. So several years ago actually government of India actually forced to adopt actually catalytic converters in conjunction with unleaded gasoline and low sulfur levels significantly reduce hydrocarbon and nitrogen oxide emissions. The second one, like a fuel, setting up like a fuel standards. So these actually help reduce exposure to pollutants like lead and benzene. Renewable fuels reduce like a CO2 emissions, like for example like solar voltaic solar PV cells, etc. And the third one, if you see like engine technologies, like computer controls, variable valve timing, multi-valve engines, turbocharging, and gasoline direct injection improve fuel economy and reduce CO2 emissions. The fourth one, like a transmission technologies, like a 7 plus speed, like a gears, dual clutch, transmission, and continuously variable transmissions, like CVTs, improve like a fuel economy and reduce CO2 emissions. Diesel filters actually, because diesel is one of the very harmful like hydrocarbons, so this will reduce actually particulate matter from like on-road and off-road diesel engines. The next one, like alternative vehicle technology, like a plug-in electric vehicles and fuel cells. So these will result into like a zero tailpipe like emissions. So there won't be any emission from the like a car itself. And better like a transportation planning and better transportation systems for passengers and freight reduce like emissions and fuel uses. So let's see like a how to like a protect like a, in another like a scenario, for example a school where like a students and teachers are there, how to improve the indoor air quality. So what to do and how to identify it. So like obviously like wherever the humans and any like a living being will be there will be emission of like a CO2. And once like a CO2 is emitted at the like a large scale of like a school, and once it is closed there will be a high like a concentration of CO2. So heightened actually carbon dioxide levels are known to result in poorer student test performances. Okay, so this is a proven fact that the CO2 and concentration of CO results into the fatigue and the low level of consciousness in the like a human brain. 400 ppm increase in indoor CO2 levels has been associated with a 21% decrease in performance on a cognitive level. So this is actually one of the findings. And if you see like a classroom CO2 levels of 2500 ppm had much worse test score than at 1000 ppm. So the moment it starts increasing from 1000 to 500, there will be a significant actually difference actually observed. And other like health effects of like a radon, for example, like these kind of like materials. So radon is an odorless, invisible, and radioactive gas. So the gas is actually responsible for about 21,000 lung cancer deaths in the US alone every year. Many countries actually require schools to test for like radon. This is due to its detrimental health effects on both staff and students when in high concentration over a long period of time. So this is one of the actually elements which we must actually take care of for like any like a such a, like a high concentration actually place where a number of like people are actually participating. More than actually 70,000 classrooms in the US have high short-term radon levels. So like a indoor air quality like affects asthma sufferers also, like the people with some special health condition. So maintaining the right humidity and temperature levels to prevent mold formation is beneficial for all, especially asthma sufferers. Toxins and chemicals like TVOCs come from like an area of everyday items including like paints and varnishes, wax and cosmetics, so and cleaning and other like hobby products, cooking. So you may be wondering where are these these compounds and these toxins and these chemicals are coming from like in any like a given at indoor air actually place. So these are the actually common material and substances which we generally use in our everyday life, and these are the actually sources of such actually toxins which are emanating from them like all the time or while on the uses. So like a total TVOCs like a volatile organic compounds can cause actually serious health effects in both the short and long term. Health effects vary from like a minor eye, nose and throat irritations all the way to liver and kidney damage or cancer depending upon the level of the exposure. So see the extent of it with the like a smaller doses to the like a higher doses, and the persistent actually exposure over a long period of time can cause actually severe health issues. What is the solution? Well, continuously actually monitoring the indoor air quality to ensure that students and teachers have actually the best of like a cognitive performance and healthy air inside the actually spaces. And ventilation is one of the actually strategic methods which is very like effective and almost like free of cost, with which we can actually make with which we can bring actually changes in like such a practices. So the ample ventilation in schools and spaces in the kindergartners can help to reduce the concentration of radon, CO2, TVOCs and other actually asthma triggers. Maintaining actually healthy indoor air quality can reduce sick leave costs and increase productivity and test scores. And in the overall like a long-term scenario also, it will save the occupants from like a severe diseases. So how this like a visualizations can be done in an like any given like a space by the, this is one actually case example I have taken. This is from actually Cornwall. Okay, so here actually a forest actually holiday lodge was actually designed without actually much causing actually much damage to the actually landscape. If you see over here from the foundation itself. Okay, so how it talks, let's go through the detail of this actually project over here. So you can see the buggy barn created right next to this road over here. This actually open fronted actually shelter sheds into slope for electric vehicles, bikes, bins and recycling. Pole construction utilizing the side timber with wildflower living roof, retaining walls of like canted logs and earth. So using the materials which are easily available on the site, and that too in the minimal quantity, and keeping it like a semi open so that it's not completely closed, and reducing actually the consumption of the material. And on the point 2, if you see, like the space beneath the building of is open for like a air circulation, and open for like a growing of the grass and bushes and things, as well as utilizing it for like a smaller area for like a creating heat pump and a cooling actually capacity and things like that. In the third point, if you see over here, landscaping and woodland management indicates like the environmental actually compliance with the local laws of this place. And the fourth one, if you see, like a high thermal performance glazing to have dusk to dawn actually automatic blinds to minimize actually light leakage in the accordance with ecologist like a recommendation. So there is like the uses of that technological like advancements of the materials is also like used to minimize actually the losses of the energy from indoor to the outdoor. So with this, if you see, like the construction fabric is shown in this pink color over here. So this is the construction fabric, highly insulated with cellulose based natural insulators like a floor, walls and in the roofing, space touch timber frame and timber sheathings, airtight construction, mechanical ventilation with heat recovery, MVHR, for moisture control, energy efficiency, excellent indoor air quality and comfort, natural daylight, healthy to build, use and deconstruct. This purple color lights you can see over here. So this indicates for the like a low impact like a foundations. So a small actually gabion platform and a concrete pad foundation raising from the building above the forest floor with minimum disturbance to the soil and the natural topography, so that there is no actually much damage caused to the actually the landform, the topography over here. So this is the actually kind of effort taken into designing such a building. You can see the pictures over here, how like easily this building is sitting over here in this like a natural setting without causing actually much damage. Another, for example, like products as simple as a chair, like how this company like NOL has actually taken a responsible actually way of fabricating like a chair in the today's like context. Okay, and they have actually also complying with the rating systems such as LEED and other like ISO standards also. So in the what are these they have actually they are assembling this product and for the LEED like a gold compliance and ISO 14001 certified like a looping manufacturing facility using like a clean technologies such as like a no ozone destroying CFCs they are using in the fabrication of this chair. Hot melt adhesive processes is like a 99% VOC free, volatile organic compounds free. Metal powder coating processes is 99% VOCs free. Chrome processes meet actually null design for the environment smart cell for the public health and environment and BIFMA level 3 requirements. Returnable packaging is used for actually tray component process. So this actually the packaging material for this product can be actually returned and can be reused. So this is one of the actually very advanced and very like a sensitive actually consideration and strategy, because much of the actually waste today is caused by the actually the packaging material itself. 100% of the electricity used at the site is offset by the wind energy, so they are actually utilizing wind energy for this actually manufacturing facility. So you can see as the component wise over here like recycled and recyclable content. Okay, it in the main actually frame of this chair. Finishes, if you see, like a powder coated paint and chrome processes actually meet the null design for the environmental guidelines. Okay, here if you see like the structural components, the constructed it is constructed using like a minimal materials and polyvinyl chloride PVC free like a materials. In the environmental like a fabrics like available with 20 plus environmental like a fabrics from non-textiles which are green guard certified and can be cleaned with low environmental impact fluids including like GS37 certified products. And in the seat foam here, right here you can see like a 7% bio-based content on an average is also used in this the seat foam over here. So this is actually a conscious effort to, first of all, if you see this design, it has the minimal number of like a components, you know, and minimal actually quantity of material is used in the fabrication of actually this actually chair. So in an overall sense there is a conscious effort from these companies. So this is a good actually example, as a good case study for you to understand like how these strategies, how the different strategies can be adopted for coming up with this sustainable solutions. How to source like a responsible like a fabric, how to source like a responsible like a textile actually fabric for our uses. So I have taken this example, like if you see like the types of like a textiles fabrics available, so they range from like organic to inorganic to cellulose based to like a protein based to even like a mineral based. So out of these like there are like several like a synthetic polymers, there are like a natural polymers, you know, and there are some like other like a highly like a cellulose based like a directly like a yarns or fabrics taken from like a bast leaf, you know, and seed hair, etc. So you can see like a how responsibly you can take. So the left half is like a manufactured yarns, on the right half is actually belongs to the like a naturally like a sourced actually yarns. So we can always have this option of choosing like an responsible like a fiber for our like a requirements in like a such cases. So you can see over here like a cellulose based, the one example which we saw in the international like case examples. So that entire like a 5 meter structure was actually fabricated out of like a natural like a polymers like cellulose and pectin, etc. And we must actually be able to identify if we are willing to like have lesser impacts in terms of like a toxic like effluents and toxic like chemicals. As you can see in this picture on the left side, it's a boy actually trying to take out a piece of maybe a garment from like a heavily toxic like a heavily polluted actually some maybe industrial like effluent like a outside area where there is a high concentration of actually hazardous actually toxins. So a direct exposure with the skin and other like body parts in such like conditions can have actually serious actually consequences on the effects of like on in the human body. So how we can actually responsibly select our like fabrics and yarns from like this circle, and how we can maximize the uses of it. So you can see on this actually sketch on the right side over here how a piece of like a cloth can be actually utilized completely for actually taking the maximum benefit out of it. So utilizing fabric that have low environmental impact and patterns that have low waste or zero waste. So this actually flow diagram represents the life cycle of a generic disposable diaper. So it's a baby diaper we are talking about over here. We may have seen it. I think every household actually uses this product, and it's a very functional and highly usable product in the recent times. But what are the actually impacts of this as a simple like material which is used by like innocent babies? So let's have a look of this. So the production and supply of raw materials and packaging. So the materials such as like a fluff pulp, you know, super absorbent polymers like a SAP, you know, polypropylene like a PP, low density polyethylene LDPs, you know, adhesives and others are actually forming the bulk of this material used for like this making of this actually these diapers. And on the component part, like the top sheet is there, acquisition and distribution layer, ADL, you know, absorbent core which absorbs actually the liquid part, you know, the back sheet for the cover and other like components, and then there is this packaging. So then happens this the manufacturing, you know, and then there are like emissions and waste, it goes for the distribution, you know, and then the product is used, is good for rather like incineration or lands up in the landfills, you know, or yeah. So this is the actually end of the life for this product. So is there any way like this can be improved? Well, this I will leave it for your your own understanding and exploration. So here if you see average products available on European market in recent years have been modeled and evaluated from cradle to grave. Results point out the importance of materials in the definition of the environmental profile of this product. These are followed by the end of life for some impact categories, while the contribution of manufacturing, packaging and transport to the overall LCA results seem of a minor relevance. Significant environmental improvements at European levels have been achieved in the recent years through the design of lighter products and the introduction of super absorbent polymers. Careful selection and use of materials at the design stage could allow life cycle impacts of products to be further decreased, while ensuring that human health and environmental risks are controlled and that functionality and performance requirements fulfilled. Indeed, potential manufacturing malfunctioning of products would result in increasing consumption. Resource efficiency is also important at the manufacturing level of optimize the in demand for materials and limit waste production. Special forms of treatment at the end of life stage of the product could instead require significant structural changes of the waste management system. Under the simplified assumption that the production of disposable baby diapers in Europe remained constant between 2005 and 2011 and that it was equal to that of 2009, that is 22,000 million units per year. It could be possible to roughly estimate the average improvements achieved in year 2011 in comparison with 2005. Savings of 1,40,000 tons of materials per year, equivalent to 1590 kg of anti-money equivalents calculated as ADP according to CML 2001. Prevention of the emission of 2020 tons of SO2 equivalents per year, 301 tons of PO43 equivalents per year, 382 tons of C2H2 equivalents per year, and prevention of the emission of 7,38,000 tons of CO2 equivalents per year calculated as GWP according to CML 2001. Savings are 22,400 TJ of primary energy per year, 90% of which are from sources that are not renewable calculated according to the CED method. So these are actually benefits you can see which has been kind of achieved in a shorter span of time between a 6 years of period. With this, I would like to bring to the end of this lecture. Thank you all.